Ionization energy is a fundamental concept in chemistry that helps us understand how atoms interact and form bonds. It represents the energy required to remove an electron from an atom. This property is crucial for predicting chemical behavior and understanding the periodic table's organization. Ionization energy is defined as the minimum energy required to remove an electron from a gaseous atom in its ground state. The atom must be in the gaseous state because we want to measure the energy needed for an isolated atom without any interference from neighboring atoms. The ground state means the atom is in its lowest energy configuration, not excited. The general equation for ionization shows how this process works. We start with a neutral atom X in the gaseous state. When we add energy to this atom, the electron is removed, producing a positively charged ion X+ and a free electron. This equation applies to any element where X represents any neutral atom in the gaseous state. Ionization energy has two important characteristics. First, it is always endothermic, meaning energy must be supplied to the atom. This makes sense because we need to overcome the attractive force between the negatively charged electron and the positively charged nucleus. Second, ionization energy is always measured for atoms in the gaseous state to ensure we are studying isolated atoms without intermolecular forces affecting our measurements. We can remove more than one electron from an atom, and each removal requires a different amount of energy. The first ionization energy, or IE1, is the energy needed to remove the first electron. The second ionization energy, IE2, removes the second electron from the already positive ion. The third ionization energy, IE3, removes the third electron. Each successive ionization energy is larger than the previous one because we are removing an electron from an increasingly positive ion. Ionization energy follows predictable trends across the periodic table. As we move from left to right across a period, ionization energy increases. This happens because the nuclear charge increases, pulling electrons more tightly. As we move down a group, ionization energy decreases. This occurs because the atomic radius increases and there is more shielding from inner electrons, making it easier to remove the outermost electron. Four main factors affect ionization energy. Nuclear charge refers to the number of protons in the nucleus. Higher nuclear charge means stronger attraction to electrons. Atomic radius is the distance from the nucleus to the outermost electron. Larger radius means weaker attraction. The shielding effect occurs when inner electrons block the nuclear charge from reaching outer electrons. Finally, electron configuration affects ionization energy because some configurations are more stable than others, requiring more energy to disrupt. Let us look at a concrete example using sodium. When we ionize a sodium atom in the gaseous state, we add energy to remove its outermost electron. This produces a sodium cation with a positive charge and a free electron. The energy required for this process is sodium's first ionization energy. Sodium has a relatively low ionization energy because its outermost electron is far from the nucleus and shielded by inner electrons, making it relatively easy to remove.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.